Okay, maybe it is just good to kind of start off from here. So, we started discussing this new way of expressing relational queries, relational database queries, called these using the tuple relational calculus. So, essentially we are kind of making use of our good old predicate logic in a slightly different form here to express queries, and these queries are expressed in a declarative manner, in the sense that we will specify what are the logical conditions to be satisfied by the result that we are seeking. Okay. And relation and predicate logic is perfectly suited for expressing these logical conditions. So, the one thing that we brought in, which is the essential ingredient here, is how to interpret the relation names as predicates, and we make a important assumption called this closed world assumption, and then assume that these relation names used as predicates will be true if you substitute the tuple that is present in the current relational instance for that predicate, otherwise they will be false. Okay. So, that is the in summary of what we did in the last lecture, and we also discussed as to how the query should in general be interpreted. So, there are going to be free variables and bound variables inside the query. So, what we will do is to consider all possible tuple assignments to these free variables in the query, and then for any specific assignment we will check whether the condition that is specified on the right hand side of the vertical bar is true. If that is the case, then we will use that combination of the tuple assignments for those free variables, that specific assignment, and then use that to produce the result values. So, please keep this general interpretation in mind, and as I was remarking in the last lecture, this kind of interpretation is again reused in SQL also. Okay. So, we started looking at various examples of tuple relational calculus. So, let me recall that we looked at this query, name and roll number and name of all girl students in the maths department. Before I proceed actually further, I would like to check if you have any doubts regarding the material so we have covered so far. So, in this lecture basically I am going to wind up discussion on the tuple relational calculus by showing a few more examples. Essentially the conceptual part of tuple relational calculus has already been discussed now. So, it is only a question of looking at a few more examples to kind of reinforce the understanding of the concepts. So, we will do that in this lecture, and sometime next week I will hold a tutorial session on this topic. So, please be prepared for that. Okay. So, to obtain the roll number name of all girl students in the maths department, we have introduced, so since we require information about students, we introduce a free variable student and then state that free variable is we use it here in this predicate student s, and then we go about specifying the various conditions that we require. So, I suppose this query, the way of expressing this query is understood. Any specific questions on this particular thing? If not, I think I discussed this in the last lecture also. We will proceed further. Okay. So, let us recall this relational scheme. It should be there with you in one of the notebook pages. So, keep it handy. Now, let us look at the other queries. determine the departments that do not have any girl students, and the information is essentially, so when you say determine the departments, I will we can assume that we need department ID and name, or department ID, one of these. So the information is present of course in the student, the general information is present in the student, and the department names and other details are present in the department. So you want to pause and check out as to how you will specify this in tuple relational calculus. Let me ask you one question. So how many variables do we require? There are two relations, and obviously two variables will be required. Which of them is to be free? Department has to be a free variable, and I think that is about it. We can write it actually now, right. So d dot name, we are only getting the name of the departments. D is a department, so variable, free variable department, and now here is another variable, the bound variable. So there does not exist any tuple assignment S such that it is a student tuple, okay, and corresponds to a female student, and the department number of that current assignment of the student tuple is in fact equal to the department under consideration. So there is remember that whenever we make some variable as a free variable, we are considering all possible assignments for this variable. So there is always a current assignment to that, okay. So and that assignment varies over the tuples in the instance of that corresponding range relation. So the department tuples we consider. For all the tuples outside that, it is anyway false, and so it will not help us, it will not be of much value to us to consider that. So for the current department under consideration, it should be the case that there does not exist any student tuple assignment to the variable S such that that student is a female and belongs to the department under consideration. So if this condition is satisfied, then that particular department contributes its name to the result. So that is how we will write the query. So note the issue of the utilization of the negation symbol here. It's available in logic, so we will use negation symbol. Now let us look at another. Obtain the names of courses enrolled by student named Mahesh. We want names of courses enrolled by student named Mahesh. There could be several Maheshes in the institute. So we want all those courses as of current date, whatever is available today. Okay, again, what should be the free variable? Courses, right? Course should be a free variable, and now the condition to be imposed is on the enrollment information about, and then of course the so do we need how many tuple variables do we need? 2 will do. Courses we need, courses we probably do not. Now names of courses, so you need a course thing, and then enrollment, obviously you need a tuple variable to be used for enrollment relation. What about name of Mahesh? So you need 3 variables. So here is how you can express this. C dot name such that C is a course and there exists student and there exists enrollment tuples, okay, which are emphasized here, that there exists S, there exists E such that S is a student tuple, E is an enrollment tuple, and S corresponds to Mahesh and E corresponds to the student. So, S dot roll number should be equal to the E dot roll number, and since we are interested in courses done by that student, so E dot course ID should be the current course under consideration. So, for the current course under consideration, we are checking this condition, that does this correspond to a student named Mahesh, right, that is all we are doing. Does it correspond to a student named Mahesh? Okay. So we are introducing two bound variable, there exists S, there exists E, and then, so it is relatively simple to write down this query. Any questions here? Okay, so let me show you another okay. Get the names of students who have scored S in all the subjects that they have enrolled. Maybe a little bit impossible, but let us assume that there exist some students like that who have scored S in all subjects that they have enrolled, and let us okay, let us also read this. Assume that every student is enrolled in at least one course. Now that we are dealing with specifying conditions using mathematical logic, okay, we should be careful about one particular fact about implications. Okay, implications can sometimes be vacuously true. Implications are sometimes vacuously true. When is an implication called vacuously true? You have seen it in discrete mathematics, right? When is an implication please recall the truth table of the implication symbol, P implies Q, right. What will happen if P is true, Q is false? P is true, Q is false, then the implication is false. If P is false, what happens? It does not matter whether Q is true or false, it is always true. So, that is called the that is the case of vacuous being. So, if the particular student under consideration does not do any course at all, so he is, so whatever courses he has done, he has got S grade, so he has not done any course, right. So, we should avoid such kind of students being listed in our output. So, we put this restriction saying that assume that every student is enrolled in at least one course. Okay, now let us focus on the main requirement here, the names of students who have scored S in all subjects that they have enrolled. Okay, remember that we are using mathematical logic, and mathematical logic fortunately for us has universal quantification. It has universal quantification, right, for all quantifier exists, is there. So, now how to utilize that and express this kind of a query. So, since it is the first time we are looking at that, let me show you the query. So, we will be using the universal quantifier as well as the implication. Though I did not explicitly mention this implication sign in the definition of the allowed formulas on the right hand side, it is clear for you that P implies Q can always be realized as not P or Q. So, as long as you have the basic conditions, you can always realize implication, the basic operators like the and, or, and negation. Okay. So, it is very convenient to have implication. So, let us assume that implication is also present and start using it right away. Okay. So, now what we are doing here is that we want information about students. So, name of the student or roll number also probably. So, the free variable is student, and now what is it, the condition that we are imposing here is that it should be true for all possible tuples that if the tuple corresponds to an enrollment tuple of the student under consideration, then the grade for that tuple should be S. Okay. So, this will capture the condition that whatever the courses this particular student has done, he has got S grade. Okay. So, those of you who are very familiar with mathematical logic, this much explanation is enough. Let me explain this query a little further. So, let us consider a person P with all S grades. Okay. Now, let us focus on this enrollment tuples. So, for all the enrollment tuples which do not have this particular person, let us say her roll number we call it, then you can see that E dot roll number equal to S dot roll number will not hold good, because we are considering a student S and S has certain roll number. Suppose this enrollment tuple does not correspond to that student, then this left hand side will be false, and so the implication will actually be true. Now, let us consider those enrollment tuples that do have this particular student's roll number. So, that means those enrollment tuples correspond to the student whom we are at present considering, person P. Okay. Now, this person has all the S grades. So, that means whenever this is true, this will always be true, right. So, for the enrollment tuples having this student's roll number, the LHS is true and the RHS is also true, and so the implication is true. So, irrespective of whatever enrollment tuple you consider, right, the implication is true, because for some cases the left hand side itself is false, and so the implication is true, and for those enrollment tuples corresponding to the student under consideration, because this person has got all S grades, the right hand side is also true, and hence the entire implication is true for all the enrollment tuples. So, that is how so for the student who has all S grades, this condition will be true and their names will be reported in the as a result of the query. Now, let us consider a person with having at one non S grade, person Q with some non S grade. Again, if you focus on the enrollment tuples, so for those enrollment tuples not having this person's roll number, the LHS is false, and so the implication will actually be true. But then there are some enrollment tuples where the enrollment tuple will have E dot roll number as this particular student's roll number, but then there is at least one such enrollment tuple where that E dot grade is not equal to S, because we know that this person Q has some non S grades, and so the implication will not be true in such situation. So, RHS is going to be false for at least one enrollment tuple. So, because of this
universal quantification which is saying that for all enrollment tuples some condition should hold good will not hold good, and so such students will not be reported as the result of this particular query. So, I hope this explanation is sufficient for you to understand this particular query. So, good, let us move on with other examples in tuple relational calculus. Now, here is another example. Get the names of students who have taken at least one course taught by their advisor. So, recall that each student has an advisor, and we are now looking for students who have enrolled for a course which has been taught by their corresponding advisor. Now, where is all this information coming from? So, the information is there in the student relation, because we want names of the students, and then we also want to bring in enrollment relation, because we have to check whether that particular student has taken a particular course, and we also have to bring in the teaching relation, because we want to check whether the course taken by the student is actually is taught by that student's advisor. So, the way we express this is as I will show you in a minute. So, basically what are the free variables that we require in this particular query? We require student as a free variable. So, we have s dot name such that s is a student, and now we are looking for enrollment tuple. So, there exists an enrollment tuple, there exists a teaching tuple such that the enrollment tuple corresponds to the student under consideration, okay. And then the enrollment tuple course ID matches the teaching tuple's course ID. So, that we are talking about the appropriate teaching tuple, and then finally in the teaching tuple it is recorded that the course is being taught by the advisor of the student under consideration. So, then we will be effectively be able to check this condition that the student has taken at least one course taught by their advisor. So, this is how we can express this query. This query is relatively simple compared to the previous queries we have seen. So, let us see, we will move on with more queries. So, display the departments whose HODs are teaching at least one course in the current semester. Okay. So, we want to now check whether what are all the departments. So, display the departments, that means we will take as the name of the department, and we want to check whether the HOD of that particular department is teaching at least one course in this semester. Okay. So, here the free variable is department, and then we want to ensure that there is a teaching tuple, teaching T, there exists T such that it is a teaching tuple, and then the employee ID mentioned in the teaching tuple should be the HOD. Remember that HOD, the attribute HOD is a foreign key in the department D that refers to employee IDs, and so we want to check whether the teaching tuple corresponds to the HOD of the department under consideration, and the teaching tuple also records that the teaching is going on in the current semester. Current means the odd 2019 semester. So, that way we can express this query by just using one free variable and one bound tuple variable. Okay. So, let us now consider one more interesting query that requires actually again universal quantification. So, here is the query. It asks for determine the students who are enrolled for every course taught by Professor Ramanujam, and assume that Professor Ramanujam teaches at least one course. This assumption is also important, because I will probably explain that later to you. Okay. Now, let us look at, let us try and actually reformulate this particular query. So, basically we are looking for students who are enrolled for every course that is taught by Professor Ramanujam, or in other words we can also put it like this, saying that the student is such that if there is any course that is taught by Professor Ramanujam, then this particular person has definitely enrolled in that. Okay. So, that is another way of putting this same sentence, expressing the same sentence. Okay. So, but that is useful for us, because we can in some sense use that directly to kind of formulate the query. So, let me show you how the query is formulated. It might look a little long, but we can go through it slowly. Okay. So, here is the query. So, just focus on that. So, we have free variable student, and I want you to draw your attention to this particular implication sign here. So, on the left hand side we have one expression, big expression starting from here and going all the way till here. Okay. And then on the right hand side we have another expression going from here to here. Okay. So, what is the query saying? So, what is the query saying? Essentially here we are trying to express the fact that for all courses the following condition holds good, that if the course is being taught by Professor Ramanujam, that is what is going to be expressed in the antecedent of this implication, then the consequent will say that the student under consideration is actually doing that course. Okay. So, that is how we will express this. So, let us again go through this. The left hand side, so we want to, in the left hand side we want to ensure that the course is being taught by Professor Ramanujam. How do we do that? That is by asking for existence of a teaching tuple and a professor tuple, such that the course ID is the course under consideration in some sense, because we are checking some condition for all courses, right. So, teaching corresponds to the course ID, and then the professor has name Ramanujam, and the employee ID of the professor is same as what is mentioned in the teaching tuple. So, that the teaching tuple corresponds to this professor. Okay. So, this is how we will ensure that we are looking at a course that is being taught by Professor Ramanujam. Then in the consequent, what we are checking is that there exists an enrollment tuple that basically records that this course which is being taught by Professor Ramanujam is actually enrolled by the student under consideration. So, the enrollment tuple corresponds to the student under consideration, E dot roll number equals S dot roll number, and then the course ID mentioned in the enrollment is indeed the course ID that we have just used here in the left hand side, that it is a course being taught by Professor Ramanujam. So, that way I mean the detailed explanation is somewhat very similar to the previous query we have seen earlier, right. So, that is how we can express this particular condition, that the students are enrolled for every course taught by Professor Ramanujam, by essentially rephrasing it as the students that we are looking for are such that if there is a course that is taught by Professor Ramanujam, then the student has enrolled into that, and this holds for all courses. Okay. So, that is the explanation for this. So, sometimes we will find this implication to be essential operator for expressing our queries. Okay. So, let us move on. Okay. Here is another very important aspect of tuple relational calculus. Now, the syntax of tuple relational calculus, as we have mentioned it, allows an expression of this kind. So, S dot roll number, where such that you said any logical expression can be there, and then student S is a predicate that we have, a primitive predicate. So, it is possible that I can simply put a negation sign there and then express not student S. Now, what are the results in this? Now, we recall that for a relation student, we are considering it as a predicate, and then for all the tuples that are not in any instance of the student, okay, we take it as a false, and for those tuples that are inside any instance of student, we take it as true, right. So, if the students, let us say some 1000 students are there, but for all those 1000 students, the student S is true. What about tuples that do not correspond to the student tuples? There may be infinitely many number of such things, because they do not match a student tuple, right. So, for all of those things, the student S is false, and because we have put a negation here, negation student S is going to be true for all those infinitely many tuples. And so, in all of them, whatever is mentioned as roll number will be reported as the result here, and that is in fact it will generate infinite number of answers. So, this is something which we do not expect to have, because in all our queries we want to have finite results, because our database essentially contains finite amount of information. So, one has to be careful when dealing with negation. So, in order to handle this, we define what is called a safe or unsafe TRC expression. So, any expression whose result, any TRC expression whose result uses either constants and values that do not appear in any instances of the database relations, we call it as an unsafe TRC expression. So, here is a example of an unsafe TRC expression, because its results will contain a huge number of values which are not really present in any of the database relations. So, one has to be careful about using such kind of sub expressions inside tuple relational calculus expressions. So, we will restrict ourselves to using the safe ones. So, unsafe expressions are to be completely avoided by specifying these TRC queries. Okay. Now, so far of course, all the queries that we have been expressing are do not have such problems, they are all safe queries. Now, let me take a few more examples to kind of again illustrate some more examples with tuple relational calculus. Okay. Before we go into that, let us remark about the expressive power of tuple relational calculus versus relational algebra. Now, we are not going into the theoretical proof of this, but it can be shown that both tuple relational calculus and relational algebra essentially have the same expressive power. So, what it means is that a query that can be formulated in safe tuple relational calculus can always be formulated in relational algebra and vice versa. So, if it can be formulated in relational algebra, it can be formulated in TRC, and if it is formulated in TRC, it can be always be formulated in relational algebra. And both of them actually express what are called transitive closure kind of queries. So, we have seen examples of that. Find all direct or indirect prerequisites of a course. So, such kind of queries we will not be able to express even in relational algebra and also in tuple relational calculus. Another example is find all subordinates of a specific employee. Okay. Now, okay, let us move on and then consider a few more examples. So, list the name, roll numbers of students along with courses, course number only, in which they got an S grade. This is a relatively simple query. So, the information comes from student and enrollment. So, it can be formulated like this. So, notice that since we require course ID which is coming from enrollment, we will make both student and enrollment as free variables. So, we will consider all possible student tuples and also all possible enrollment tuples, and if they match, that means the roll number of the student is same as the roll number mentioned in the enrollment tuple, and the enrollment tuple records a grade of S, then we know that it corresponds to a student who has got a S grade in some course, and so we will report the name of the student, roll number of the student, and also the course ID. So, notice that you would in all the courses in which that particular student has obtained an S grade, his name and the course ID will be reported. Okay. So, this is a relatively simple query. So, let us try this other query. List the name, roll number of male students being advised by lady professors along with the name of the advisor. Okay. For some reason we just want to figure out who are all the boy students who have been advised by professors who are women. Okay. So, this information comes from student because advisor is mentioned in the student relation, and then gender of the professor is mentioned here, and so we need both these. So, the way you can formulate this is like this. Again, we have two free variables, student S and professor S, and we are looking for the student being male and professor being female, and student's advisor is this professor. So, you recall that advisor is a foreign key in student referring to the employee ID in professor, and so we will be able to match the student's advisor to the professor using S dot advisor equals P dot employee ID, and in such combination we will report the student as well as the professor, roll number, name of the student and the professor's name. Okay. So, this is also very similar to the previous query. Okay. So, let us move on to another query. List the name, course number of prerequisites of the course data mining. So, there is a popular course called data mining. So, we want to know what are all the courses that have to be done before I can enroll for data mining. So, that means they are prerequisites of data mining. Now, the course name has been given. So, we have to get the course ID. So, that will come from course relation. Then the prerequisite information is available in the prerequisite relation. So, it basically has two attributes stating that the first attribute is a prerequisite for the second mentioned course number. So, both are actually course numbers. So, this course number mentioned in the first column is a prerequisite of the course that is mentioned in the second column, and notice that a course can have multiple prerequisites. So, let us see how to formulate this query. So, we want to report the course number and also the name of the prerequisite. So, we will introduce a free variable on course, and then report course ID, course name such that C is a course, and now we are looking for information condition that this particular course is indeed in fact a prerequisite of the data mining course. Okay. So, that means we are checking for the existence of two tuples, there exists D and there exists Q, such that D is a course and its name is data mining, right, and the Q that we are looking for is a prerequisite tuple, in which we are looking for the Q dot course ID should be the course ID of the data mining course. Okay. So, that means the second one. Okay. So, Q dot course ID is equal to the D dot course ID, where D is actually at the tuple corresponding to the data mining course, right. And then we are checking whether the outer course that we are considering is indeed a prerequisite of this particular course. Okay. So, this Q now this prerequisite tuple corresponds to data mining course, right. So, in that whether Q dot prerequisite course is equal to the course under consideration right now, that is what we are looking for. So, we are looking at all possible courses, and if that course happens to be a prerequisite of the data mining course, then we are reporting its course ID and course name. Okay. So, how we do that is we basically look for existence of a course called data mining, and then existence of this prerequisite tuple, in which that course data mining's course number is mentioned as the right hand side, and then the course under consideration is mentioned in the left hand side. That is when it becomes a prerequisite for the data mining course. So, that is how we can handle this particular kind of query. So, with these examples I want to close the tuple relational calculus module, and I urge you to practice express different example queries using tuple relational calculus, and gain a good grip on how to express queries in tuple relational calculus. Thank you.